Hello and welcome. I'm Kamal Takodra. I'm a technical market engineer in the HP Aruba networking switching business unit. In this 10.15 update, I'm going to be discussing multicast route leaking. So let's get into it. So today's agenda will have an overview, cover some use cases, configuration, best practices, troubleshooting. Then we'll have some links to additional resources. In 10.15 0005, we've now introduced multicast Inter-VRF route leaking. So that basically means that multicast from one VRF can be leaked into another VRF. And in this example here on the graphic, we can see we've created a services VRF. And this is actually feeding two different VRFs, a media VRF and a VRF called surveillance. And both of these groups are interested in different sources and groups, but it's all fed from this VRF at the top. So to have this in place, you have to have in situ unicast IVRL. So that should be operational for multicast IVRL to function. So your route imports and exports effectively using BGP is the dynamic way to do that. Then with multicast IVRL, we use static RP today. We support both IPv4 and IPv6 addressing. And we have a new CLI under the PIM routing. So the assumption is obviously you have the unicast routing in place. And then what we do in this example, I'll talk over it in a bit of detail, where we have effectively the services VRF that we've identified in this diagram. This is our source VRF. We've enabled it. We've got an RP in there, which is in that VRF. And then we take VRF media here. And again, we enable it. We point to the same RP, which has been leaked via unicast routing. And then we put in the new command IP multicast RPF select VRF sources. So this is the services VRF being leaked into media VRF. And likewise, we do the same for the surveillance VRF, and we leak in the services VRF into that. And that's quite simply how it's done in configuration. So in terms of supported platforms that can do the multicast IVRL, we start at the 6300, not the 6300L, then the 6481, 8320, 8325 and 8360 upwards, and not the simulator OVA. So let's look at some use cases. So first of all, let's look at this campus architecture. We have a couple of buildings and we have an on-premise DC. Well, this is going to be our source VRF in effect, which has the rendezvous points here in that VRF. And we're going to be leaking to VRF B in building 1 and VRF C in building 2. And how we do that is we have multicast IVRL on these core switches. And this allows leaking into VRF B and C respectively. Now the next use case is a multicast IVRL between a non-VXLAN and a VXLAN network. So basically we have the source VRF with a rendezvous point in a non-VXLAN network, and then we want to feed that VRF or multicast sources from that VRF into a couple of different VTEPs or few VTEPs that have VRFB and VRFC respectively on them. And this is done at the border VTEP where we do the IVRL as well as we do the unicast import and export of the routes as well. So let's go on to some configuration now. So in the configuration, we're going to take a look at this typical topology. So we've got layer 3 between the core and really the source, and then we've got layer 2 between this collapsed core and the edge devices. So the VRFs are as distributed, and what we would do in this scenario, and not necessarily the only way to do it, but we would run eBGP between source and the MVRL point. We're running OSPF between these VSX pairs actually, and then we're just running layer 2 between the VSX pairs and the access, and we're trying to distribute this VRF blue into VRF red and green respectively, and we'll cover that in the next slide. So first of all, look at the VSX primary node, which happens to be the one on the left here. So basically what we're doing here, using our import and exports, we're just doing our unicast VRF route leaking, and we'll be using BGP for that, and that's pretty much all the way. We have some connectivity as well. Some of this is already covered in the configuration guides, white papers, and other transfers of information, which you can find on our ABC networking channel. So we have some OSPF routing between the VSX pairs, and then we have some BGP that's helping to mix the VRFs, as well as peering to the device where the source is. And then finally we have the actual IVRL, multicast IVRL mixing, where we got the source blue defined, and then we have our VRFs that we're effectively leaking into, and that's green is the host VRF and blue is being leaked into there, and similarly red VRF is the host VRF and that's being leaked into, and we have blue leaking into that. Now you must define the RP statically. Right now RP address is the same for each VRF, which belongs in the source VRF, which is learnt through the unicast routing. Now next we go to the VSX secondary, so very, very similar apart from some IP addressing. Again, we've got some we've got all the import and export of the route targets. We've got the OSPF between the two VSX pairs, and then we've got the BGP, and we are pairing eBGP to the blue VRF source, and then similarly we have the source VRF blue, and then we have the hosting VRFs that are being leaked into with blue into both the red and green VRFs respectively. So now looking at the configuration, edge and access. So all of these switches on the edge here with the different VRF red and green are just sort of layer 2 access, with VLANs being trunked up to different lags. So let's look at VRF green, for example. We've got VLAN 300 here. It's got IGMP snooping. We've got a couple of lags which are defined on for the uplinks, and then we've got the access ports, which happen to be, one of them is a trunk and one of them is just an untagged port in VLAN 300, so nothing complex about that. And then for the source, we're just using BGP, and we've just got defined in a VRF here with some connectivity. Important to know that we've defined the RP here. This is our loopback RP, in this instance 5.5.5, and we're statically even pointing to that here. And we did see in the other configurations that everything was being pointed to this RP when we were mixing, and this is really just the eBGP connection to the two VSX pairs. So no real mixing or multicast IVRL here. This is all unicast stuff, and this is all layer 2 stuff, and all the sort of driving force is here on this VSX pair. So that's really a brief overview of configuration. Now, there are many different ways of doing this. So we did, in the previous example, we did eBGP between the VSX pairs and the source, and then we did layer 2 between the VSX pairs and access. Now, depending on how you want to do it, you can just do OSPF everywhere, and then we have BGP between the VSX pairs only, and then we have OSPF in between the access and the VSX pairs, and even have VRFs also layer 2 if you wish. However, what doesn't change is that the fundamentals of mixing on both of the VSX pairs, in this instance we still use the same thing. We have the VRF blue, which is the source, then the hosting VRFs have the source injected into them using the IP multicast RPF select command, and the same for VRF red. So the key is we have our multicast IVRL point in a single place. It's exactly how you would do unicast IVRL, in fact, and just attaching these configs onto those devices to enable the multicast IVRL. So in terms of best practices, it's quite a lot of common sense really, but use dynamic unicast IVRL, and this must be in place prior to the multicast leaking. Don't use overlapping IP address space, and this should be avoided, otherwise you're going to get unpredictable results. Today you can only leak 8 VRFs, and then generally use a central high availability node for the leaking, i.e. using VSX pairs, or use some sort of redundant chassis like a 6400. So let's go on to some troubleshooting. So I've listed some troubleshooting commands. So if you have a configuration and you're basically got a red, which is our hosting, and your VRF, and you're putting blue or leaking blue into that hosted VRF, here's some useful commands. So you can do a show IP PIM, and you can see the multicast, you can see the IVRL status for that PIM routing, and you can see we've got it enabled, so that's a good clue that it's enabled. Now you can also do a show IP PIM or VRFs, and we can see that a leak is active as well, so that's a good clue that things are operating as they should be. So looking further at some more interesting outputs, so we got VRF red, which is effectively our hosted VRF, and we're leaking blue into that. And when that happens, we can see that blue in red's perspective is the egress VRF. So do show IP PIM VRF red, we can see that the egress VRF, which is blue, which if you recall from what I said from the start of how we do the RPF check, and we see the source, and that is the source, and that is our egress VRF from the hosted VRF's point of view. Now if we look for the multicast address or the mroute address in terms of details, we can see that VRF blue, which is our leaking VRS, is forwarding to VRF red. So in terms of additional resources, I think the only thing that's really relevant is the dynamic IVRL, and you can see that on our YouTube channel. Have a search for that or go directly to this link, and also look at our user guides or multicast, which will give you some valuable information about this specific feature. So all that remains for me to say is thank you for watching, and I hope that was useful to you.